Hello students, my name is Satyajit Pal and today we are in the continuation of the previous lecture that we did on C++ functions. So in the previous lecture we had studied about what is a function, then we also did the two types, the inbuilt functions and the user defined functions. So in the last class we did programs on the user defined functions. So today we will see what are C++ library functions. So library in here means the compiler. So there are certain functions which are known as library functions. Now what are library functions? The functions other than the user defined functions are known as library functions. Now programmers can use library functions by invoking the functions directly. They don't need to write the function themselves. That means since the user defined functions were defined by the user itself. For example, if I write add, and if I write a certain piece of code over here, int a, b, and cout a plus b. So as you can see here, let me make the font a little bit bigger. So as you can see, if I define a function named add and declare some variables and write what the function will be doing for me. So this function, what you see right here on your screens, this function that you see right here on your screens is a user defined function. Okay. Now this function will work according to the user, but this code inside this function, it is written by the user. It is not predefined inside the compiler, nor it is present inside the library. Okay. So C++ library functions are just the opposite. Okay. In the user defined function you have to write the code by yourself, but programmers can use library functions by invoking them directly. Okay. Programmers can use the library functions by invoking them directly. They don't need to write the functions or write the function definition from themselves. Okay. Now let us look at some common examples. The commonly used examples that we have are sqrt, abs, isDigit, etc. So all these functions, for example, sqrt abs, we need to include the c dot math. That means the library functions can only be used if we have a particular header file. For example, if we have math.h, we can use this mathematical functions which are predefined. Okay. So let us understand this with the help of an example. Let me highlight this. Okay. So what you see on your screens right here is a very simple program of to demonstrate what is the use of library functions. Okay. So here I have included CMath as a header file, and the previous IO streams is there. In here I have declared two variables. One is number and other is square root. So number, I am fixing this value to 25.0 as because I have given double. Okay, if I would have given here int, then I would have written it only 25. Now in here this program, what it does, see what is written here inside the comment line. sqrt is a library functions to calculate the square root. Okay, so as you all know that square root of a number, for example, let's say I have a number 36, the square root will be 6, right? So in this way, by using this library function, I can directly calculate the square root of any number. Okay. Now as you can see, I am directly writing this function and passing this number as a parameter. Okay, I am writing this function, sqrt, and passing this number this number as a parameter. This number will be the parameter to this function. Okay, and after calculating the square root, the value will be stored in this variable named square root, and lastly we display square root over our screens. Okay, and return 0. Okay, so in this program I have fixed this value to 25.0. You can take it either from the user also, or you can fix some other values. Okay, now let us try this piece of code over here. This is the piece of code. Okay, so sqrt, this is a library function to calculate the square root as given. Okay, now let us try and run this code. Okay, error 0 and warning 0, that means the program is correct. Now let us try and run this. Okay, so as you can see on your screens, the square root of 25 is equal to 5. This is being displayed. Okay, let us make some changes over here and see whether it actually calculates some other values or not. Let's try and make it 36. Okay, and I'll go and save it, and I'll run it again. Okay, yeah, right. So it is calculating the square root of 36 is equal to 6. Okay, now let us try with some other value. Let's say 100. Yeah, the square root of 100 is 10. It is showing as such. What if I change it to 120? Okay, so if I change it to 120, you can see on your screens the value is 10.9545. Okay, so this will be the value. So as you can see, I have just called this function and it is directly giving me the square root of any number that I am putting it. Okay, I'm giving any value to this variable named number, and I'm passing this number as a parameter to this function. That means I'm passing it here. Okay, the value of 100 gets copied to this function named number. This value 100 gets copied to this number, and the function named sqrt calculates the value of whatever the value of number is, and it stores the result in this variable named square root. And lastly, if we display square root, our actual square root of the number is being displayed. Okay, so this is how you use the library functions which are already written inside the compiler. And let me repeat it once again, that we shall not be writing codes or the function definition for library functions. We just call the library function and use the requisite header file which is required to use this kind of functions. Now let us move to the next part. So here we have something very interesting known as C++ function overloading. So function overloading, what do you mean by this term? Okay, so in layman's language, if I were to explain you that what is function overloading, that means having a function with the same name but different number of parameters. Okay, suppose if I have a function named add, let's say I have a function named add. Suppose let's say I have a function named add, and in the same program I have a function named add as well, but in here I am having 2 and 3 as parameters. Okay, look at this very closely on your screens. I know it is not visible. Okay, so here we have two functions named add, one is having no parameters, the other is having two parameters inside it. So in here, as you can see, the two functions are having a same name. Okay, so this, my dear students, is known as function overloading. That means two functions are there within the same program, but they share a same name. So as you can see from the definition, in C++, two functions can have the same name but differ in the number or type of arguments. Okay, if the number or the type of argument passed is different, these functions are said to have same name but different arguments and are known as overloaded functions. We'll understand with the help of an example, but let us look at the definition part first. Okay, now function overloading is a feature of object-oriented programming where two or more functions can have the same name but different parameters. Okay, just look at this part. Function overloading is a feature of object-oriented programming. Now, object-oriented programming means in here it is a feature of C++. Okay. Now, as we know that C++ is a object-oriented programming, so function overloading is a feature of C++, where two or more functions, see, two or more functions can have same name but different parameters. See, if it is a single function, we cannot say it is overloaded. So at minimum, there has to be two or more than two functions to make it overloaded. Okay, now when a function name is overloaded with different jobs, it is known as function overloading. When a function name is overloaded with different jobs, it is known as function overloading. In function overloading, function name should be same and the argument should be different. Please focus on this part. Yes, in function overloading, the function name should be different and the argument function name should be different, sorry, same, and the argument should be different. That means what? That, as I showed it in the previous example, for example, let's say, let us take these examples. So in here you have a function named test. Okay, you have a function named test. So in the first one, this in the first one, you don't have any parameters passed to it. Okay, in the second one, you have just one parameter passed to it named int a. In the third one, you have different parameter known as double a you have passed, and in the fourth one you have passed int a and double b as the parameter. Okay, int a and double b as the parameter. Now you can see that all these functions test, test, again test, and the last one is also test. So as explained in the above line, function overloading, the function name should be same and the argument should be different. That means in here, as you can see, every function is having the same name, test, 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 and test. But the number of arguments that you have passed here is different. Now let us demonstrate an example of function overloading. Okay. Now in here, as you can see in this program, we have a function named print. We have a function named print. If it is visible, yes. You have a function named print. In here, firstly, you have passed a parameter int I. In the second print, I have passed a parameter double f. And in the third print, I have just put a character constant pointer c. Okay, I've just passed this. Now, if I try to run this program with the help of different parameters, see, in the main function I have passed the parameters 10, 10.10 and just 10. Now here just 10 will be just printed as a character constant as given here. Now let us run and see. So I have pre-written this code. Now let us run and see what will be the output. Okay, so as you can see on your screens, the same function is being called, the same function, print. These are three functions. Okay, these are three functions, and print. These are called, the same function is being called three times, but what happened is that the the number of arguments is same. That is, each time this function is having a single argument, but the type of arguments is different. The type of argument is different. One is having char, one is having double, one is having int. Okay, so this can be an example of function overloading. We can try some other type of examples also, where we have some different number of parameters. Okay, different number of parameters. Now let me run this code once again. Let me save it. Okay, so it is showing sum equal to 12 and sum equal to 15. Now what happened in this program, let us see. So example of function overloading. Here we have a function named void add, where you have two number of parameters, int a and int b. Okay, so this is the function's definition part. As you can see, this part is the function's definition, where cout sum equal to a plus b. And in continuation, I have another function named add, and here I have passed three parameters, int a, int b, and int c. And here this function, what it does, this function's definition is given. It will do sum of a plus b plus c. Okay, so here the number of parameters is different, but the function name is same. So this also can be an example of function overloading. Here you have two number of parameters, in the second one you have three number of parameters, and now when you call this function, you'll pass some values. You'll be passing values 10 and 2, 5, 6 and 4. So if you look at the code here, a plus b plus c, that means 5 plus 6 plus 4. The value which is shown is, sorry, if I run this, 5 plus 6 plus 4, remember, 5 plus 6, 11, 11 plus 4, 15. So the second function will give you a value of 15, and the first function, which is called, will give you just the value of a plus b, that is 10 plus 2. So as you can see, the result is being displayed as 12. The result is being displayed as sum equal to 12. Okay, so you can call this function. So this part is the function call. But you see right here inside the main function, this part is the function call. I'm calling the add function twice. Once I have passed the parameters 10, 2, that is two number of parameters, and otherwise I have passed three number of parameters to the second part or the second function. Okay, now since these two functions are having the same name, this, so it is known as function overloading. So I hope this part is clear. Okay, so likewise I can have another function. Let's say I can put this again. I can put this part again. I can put and pass a plus b plus c plus d like this, and I'll call this function from here. So what if I add all this function again, but this time I add one more number of parameters. So what should be the total? 5 plus 6, 11, 11 plus 4, 15, and it should show 19. Now let us run and save and run this. Yeah, correct. So in the first function we have two number of parameters. In the second one we have 3 number of parameters. In the third one I have 4 number of parameters. So as you can see, these are the function calls, and I am passing the values or arguments to this function. Okay, so this is how you can pass different number of arguments to the same function, and this, my dear students, is known as function overloading. Okay, so I hope it is clear to you. Now let us look at what are local and global variables. So in a function, local variables are what? The variables which are inside a function or a block are known as local variables. Okay, in the definition of function parameters, which is known as formal parameters, okay, there are three places where variables can be declared. Either it will be declared inside a function or block, then it will be known as local variables. If it is function passed as a function parameter, it is known as formal parameters. And if it is passed or declared outside the function, then they are known as global variables. Now let us try and understand this with the help of this code. If you can see right here on your screens, this is a local variable, as because see, int a, int b, int c, all these are local variables. You know why? Because it is passed inside this block. Okay, it is passed inside this block. So what did we understand from the definition? That local variables can be used only by statements that are inside the function or block of code. Okay, local variables are there inside a function block. So this is the main functions block, and these variables int a, int b, int c, all these are inside this block. So hence they are known as local variables. Okay, so let us try and understand some other example to know what is to actually know what is the difference between local and global variables. Okay, so as you can see on your screens, this variable int g equal to 20. Okay, and in here I have another variable known as int g equal to 20. Let me make it some other color. Okay, so as you can see on your screens, int g equal to 20. So this variable is outside this block, right? This variable int g equal to 20. This variable on your screens g equal to 20. It is outside this main functions block, and since we know that global variables, the global variables are those which are outside the block of the function. So outside of all functions are known as global variables. So any function which is declared outside this block what you see right here, this will be known as a global variable, and this variable can be used all throughout this block. This variable can be used all throughout this block. Okay. Now, what is a local variable? Local variable will be local to this block. Okay. Local variable will be local to this block. And if I'm trying to access this global variable, I will do it with the help of a scope resolution operator. Okay. Now let us try and run this. One zero two zero. So first of all, the local variable was called and it showed this value as 10. Okay. And secondly, the global variable was called with the help of this scope resolution operator and it showed the value 20. So as you can see, since I have not given any space, it is showing 10 and 20. Okay, it is not 1020, it is 10, 10 and 20 separately. So this is what is known as a local variable and global variable. Local variable will be local to this block. Okay, as you can see, int g equal to 10 is declared inside this block. It is a local variable, and if I try to declare it outside this block, if I try to declare this g equal to 20, g equal to 20 is outside this block, so this will be a global variable. Okay, so I hope this is clear, and this will be all for today. I hope to see you all in the next class with some more example on functions. Thank you.